Section 11.3, polar functions. So, what will we learn about today? Polar coordinates, polar curves, that's about as far as we go today. Then our second part of this section will cover slopes of polar curves, areas, and then looking at that lovely gallery. It's kind of cool in the back of the chapter. So today we're just reviewing the amount of polar content that you guys have done in the past, get you working with polar again before we start working with calculus. So we deal with a lot of rectangular functions where we go right x and up y to get to a point, or left x and down y to get to a point. So to get to the point 2, 2, which we have on our screen, we would go right 2 and up 2. Well, we can get to that same point using a different coordinate system. And the reason we have this different coordinate system is sometimes it makes different functions easier to work with. Again, if we can always write something in a different way, sometimes we can do more with it. So, this second coordinate system is the polar coordinate system. And our points are written as r comma theta, where r is the distance to the point after we rotate some angle theta from the positive x-axis. So if we look at the point 2, 2 in rectangular, and if I were to draw in just a direct line to that point, like that, what angle is formed here? It is pi fourths. We are going right 2 and up 2. So if we did the inverse tangent of 1, we would get pi fourths. So that is the angle we would rotate, and then we have to figure out how far do I have to go in that line to get to the point of interest. Well, how would I get the distance on that line? Use the triangle and use what? Pythagorean theorem, exactly. 2 squared plus 2 squared is the square root of 8, which is 2 root 2. So our point in polar would be the distance along that line, which is 2 root 2, comma pi fourths. Okay? Can somebody give me another set of coordinates for that exact same point?
2 root 2, what? Like 9 pi fourths?
9 pi fourths. Yeah, absolutely, that works. 2 root 2. I can get my pen to go. There we go. 2 root 2, 9 pi fourths. That's the same angle. Give me another one. How about one with a negative r? Boston?
2 root 2, negative 7 pi fourths.
Well, we could do that too. 2 root 2, negative 7 pi fourths. Connor, do you have one with a negative r?
Negative 2 root 2 and 5 pi fourths.
There we go. Negative 2 root 2 and 5 pi fourths. All of those will work. If I go 5 pi fourths, that brings me to the third quadrant. I would be down here. And instead of going out towards 5 pi fourths, which would be positive 2 root 2, I go negative 2 root 2 to bring me back up into the first quadrant. Is everyone okay with all of those options? Okay. You'll be doing this tonight in your homework, finding other coordinates to represent the same point. All right. Now, I'll put some extra examples on tonight, but I want to make sure we get to just the basics of converting between polar and rectangular. If you recall, anytime we need to find our x component, it involves cosine in our right triangle. So x is equal to r cosine theta, y is equal to r sine theta, x squared plus y squared is equal to r squared, and the tangent of theta is y over x. These are the key conversions between rectangular and polar. So let's use these conversion formulas to help us do example 4, which says use the polar rectangular conversion formulas to show that the polar graph of r equals 4 sine theta is a circle. All right, so what can I replace r with from my formulas? Square root of, right? X squared plus y squared. Is equal to 4. What can I replace sine theta with? A little more.
Y over R.
Y over R. All right, I still have an R in there, so I'm not in Y's and X's, and I certainly can't tell yet that that's a circle. So we want to get it to the standard form of a circle that we're used to seeing. Let's get that R out of the denominator, and we're going to have R root x squared plus y squared is equal to 4y. Help me get rid of that R. What can I do? Same thing again. Square root of x squared plus y squared times the square root of x squared plus y squared is equal to 4y. And yes, our square roots go away, and I now have x squared plus y squared is equal to 4y. That does not look like the standard circle formula yet. So, welcome back to Algebra 2 and completing the square. So we have x squared plus y squared minus 4y, I'm going to leave a big blank, equals 0. So, this circle, if it comes out to be a circle, we can see it's already centered at x equals 0. I want to find where the y is centered at. So to complete the square, we're going to add something to both sides. How do I get what goes in that blank? Yep, there's half. Half of negative 4. And then what? Square it. And that goes in both of the blanks. If we add it to the left, we must also add it to the right. So now I have x squared plus y squared minus 4y plus what? 4 equals 4. Well, we're getting closer. Now I just need to rewrite that trinomial as a binomial squared. That is y, and what do we have in the binomial? Y minus 2, thank you. So I have x squared plus y minus 2 squared equals 4. And this is a circle whose center is where? 0, 2. And whose radius is 2. Check. That was a nice trip back in our memory. All right. So, this is about all you're going to be doing tonight. You will be converting. You'll find rectangular coordinates for points with the given polar coordinates. So you'll be converting from polar to rectangular using those formulas. And find two different sets of polar coordinates, quiet please, for the points with the given rectangular. That's what we just did on the front page. Graphing with polar coordinates. These get a little bit tricky, only in finding the window. The window, if you recall, tends to be the toughest thing. Most often we have a window of 0 to 2 pi, with our theta step being pi tenths or pi half, something small. But as we move into the calculus of polar functions, we have to be a little more specific about our windows and about what part of the curve we want to see, because we do not want it to go around once and overlap itself. So we'll be a little more specific when we get to the calculus. But for now, start with a 0 to 2 pi to see if you get the whole window. And then we'll get a little more specific when we start working with the calculus. Okay? So homework for tonight is section 11.3, and I think it's 1 through 31I. Page 552, I believe. 1 through 31 odd.
564.
564. 552 is when I went over today. All right, and you can get. All right, so we have extra examples added in, so if you need any further assistance, just scroll through and you can pause on the examples that you're interested in. Example 1.
example 2. And example 3.